What is up, beautiful people? Welcome to another episode of the Game Engine series. How's everyone doing today? We're live. Hi from Bendigo. Wow, that's close. So today, let me just get organized. I'm never organized for this stuff. So, last time, Vague Lobster, thank you for your 2 years of subscribing to Twitch. Very, very appreciated. It's because of people like you that we're here on this fine Monday evening, at least in Australia, doing our game engine work. We've started on this whole C# scripting thing, right? So it's pretty exciting for those of you who are unaware. What we have been doing is implementing C# scripting, or like by implementing C# scripting, I mean adding like the feature of C# scripting into Hazel 2D, which is the Game Engine series version of Hazel. Game Engine series version of Patreon. So I was thinking about how I was gonna say that if you guys want to support the series, patreon.com/thecherno is the best place to do it, and you'll get access to Hazel 3D, which already has C# scripting, thanks to Peter, who is in the chat. Well, actually, no. Actually, it's thanks to me. I did the initial implementation, and I will make sure that everyone knows that. But these days, Peter is the man. So let's just get the pecking order straightened out. Yeah, okay, fine. We'll say Peter made it good. I'll let you have this one. But anyway, so yes, and without further ado, we should probably jump into it. Last time, let's take a look at what we did last time. By the way, as a quick note, Hazel 2D, of course, is all fully free for all of you guys. It's just on GitHub. So if you go to github.com/thecherno/Hazel, which is loading on my other monitor. Looks like my internet is a bit slow. Still loading. Okay, there we go. So, this is up on GitHub. Link will be in the description below if you're watching this on YouTube. Otherwise, it's just github.com/thecherno/Hazel. We have a scripting branch, and this is like where everything is for the kind of work that we're doing today and for the, you know, for the foreseeable future. Probably for like a month or a few months or so. But basically all the kind of stuff has been pushed here. So if you're wondering why, like, where is it? It's not in the main branch or the master branch. It's in the scripting branch, okay? So if we take a look at what we did last time, it was basically this. Now, I'm actually kind of enjoying this project because usually, like, a lot of the times, like these videos, I'm just gonna adjust the mic, hopefully it doesn't hurt too much. Usually these kinds of videos, I was gonna make that, whatever. These kinds of videos are me just kind of doing exactly what I know how to do already because I've done it before, and it's just kind of like a tutorial of me writing down the code and teaching you guys and all that stuff. But the reason why I kind of like this C# scripting adventure is because I have no idea what I'm doing. I did the initial implementation in Hazel, like in Big Hazel, like a few years ago. But then like a lot has kind of, well, not a lot has changed, but like we do things differently. And so Peter is in the stream kind of teaching me as well. So this is cool because it's me actually learning new stuff, and I always love learning new stuff. So yeah. So without further ado, just adjust that light a little bit. Without further ado, let's dive in. How the tables have turned. Yes, how the turntables. So, yeah, I'm not going to go over last episode's code. Obviously, you guys can see that on YouTube on my Cherno Unplugged channel. Toby1308, thank you for the tier 1 sub. Appreciate the support. Yeah, I'm not going to talk too much about what we did last time, but it was basically just the beginning. The main thing that I want to accomplish here today, the main thing, right? We'll see how we go. Like, we might do a number of things, but the main thing is I want us to be able to successfully call a function from C# that is in C++, right? So we want to call a C++ function from C#. We have our kind of Hazel script call. We have this main thing, and then we have a bunch of these functions. And at the moment, we're able to call all of these, including the constructor, by constructing this new kind of main object, right? We're able to call all of these from within C#. In fact, that's what we're doing in this kind of script engine in init mono function for now. We can call all of these functions by calling mono runtime invoke, and that's fantastic. However, what I want to be able to do is obviously call like a CPP function from within one of these, right? So how does that work? Now, there's actually a few different ways to do it. Like, a few of you may be familiar with like using Invoke, right? Which I wasn't really planning to talk about, but we can take a look at it. So it's called Invoke or Platform Invoke. And so what we can actually do is like build, like, for example, a DLL. Ralph Yeager, thank you for the sub. Appreciate the support. We can just call, like, you know, we can kind of make the signature of the function here, mark it as an extern, do a little DLL import, build a DLL that's native, and then we can kind of call that from here and then do potentially some marshalling, right? So the hwind here is an in pointer, and so we can kind of take that in, some strings and whatever, and yeah, like that's one thing we can do. Obviously though, for Hazel that doesn't really fit because we don't build Hazel as a DLL. And nor do we really want to, right? Invoke is something that in general I think is great if you have like a library that is native and you just want to add that to like a C#, an existing C# application or a significant existing C# platform. That's cool, but that's not really what we're doing here, because if you think about it, right, the way that I kind of think about this whole Hazel situation, if we look at what Hazel is, yeah, what I kind of think of this as is like, you know, Hazel is like everything. Hazel is the universe. Hazel is like the core engine, right? And inside the core engine, we have all these different systems. Like we have rendering, and we might have like, you know, rendering. We might have like physics. We have all this stuff going on, right? And then one part of it is essentially some kind of scripting logic and behavior. And remember, what is this scripting doing at the end of the day? Right? Well, to be honest, it can do everything. Like, there is no limit really to what we could do inside scripting. That's what makes it so powerful, because we're able to use a programming language to write whatever on earth we want. Yeah, so like the thing is, like, you can boot up, like as an example, we'll use Unity. You can boot up Unity and then you can proceed to write your own kind of game engine within Unity and then make that just render to like a buffer and display that in the game in Unity, and that's your game, right? Or you could write like this whole e-commerce platform or something in the C# code, maybe even call other libraries in C++ or whatever, and then Unity just hosts it, right? So really there could be anything could happen here, and that's the exciting part of scripting, right? It doesn't just have to be engine related. However, it's really important to note that the primary thing about scripting, and the thing that makes it scripting and not programming, specifically when we're talking about like a game engine, is what exactly? Is the fact that what I see this as at the end of the day, right, is puppet strings, right? What are we doing? We are controlling the engine, which is represented by this stickman. We are controlling the engine's systems and manipulating data by pulling puppet strings using this C# scripting language that we have, right? So that's really, really important to note. And that's what really changes everything. Like, we're not really trying to necessarily, we'll get to this a bit later, but we're not necessarily trying to provide people with a programming language where they can build anything that they want, even though, yes, that's what it's used for, and you can do that, and you probably want to do that, and we'll get to that later. But the primary like definition really of scripting, when you think of it, is it's kind of like you're writing a script for what you want the engine to do. It's a way for us to control these engine systems and give us more control into them than just simply using like a user interface. And of course, scripting can take many forms. We could have a user interface in the form of like visual scripting, something like Unreal Engine's Blueprint system and like Unity's visual scripting or whatever, right? All of that's fine, and all of that might be desirable. But the reason why I'm drawing so much attention to this is because I think it's really important to note that at the end of the day, what we're really doing is we are just controlling or trying to control these systems using some code and logic, right? I mean, think of it this way. If you have a character inside your game, maybe you have like some kind of ball, you want it to move right or you want it to move left, well then what do? Inside the script's onUpdate function, right, or whatever it's called, you might want to say that if I press like, I don't know, the W key, or let's just say the D key to go that way, if the D key is pressed, what do? Maybe I add some kind of force to the rigid body that's on this. And I say, hey, go that way. Right? So what are you doing there? Well, you're basically reading data from the engine's input system, and you're sending data or sending an impulse into the engine's physics system, right? So again, what have you done there? Have you really used the programming language? No, like in a way, right? You see what I'm saying? You've kind of just called a C++ function to get input data, and you've called a C++ function to get physics data, or to send physics data, to send some kind of trigger or whatever, or call a function with some data probably as to like, you know, how much force you want to add into the physics engine. And so I think it's really important to picture this, right? However, obviously, there could be a whole, like, huge, like, plethora of stuff you might want to do, right? This is a very simple case. And in, like, a real game, there might be so much stuff that goes into it. Apart from just calculating stuff, you might need to interface with things like networking. If maybe this is a multiplayer game, you might need to serialize or deserialize certain data and check certain states across different entities, right? There's a lot of stuff that might actually go into this. And so because of that, it's very popular for us to also want to build up some kind of metagame system inside the programming language. And this is really why I picked C# as the language for this, because that's another thing. I don't really want to spend too much time talking about this today, but the reason why I picked C# for Hazel over something like Lua, which was like a lot of people mention, or Python, which a lot of people also mention, right, is ultimately because I think C# is a really good programming language. It's more than just a scripting language. It's more of a programming language. Its library is incredibly thorough, right? And it's the way that it's expressed, its syntax, and its actual built-in language features as well are very, very powerful and extensive. And because of that, it makes it more suited for programming, which to me, like, I think is really important if you're actually building a serious game. Because if you're building a serious game, serious, thank you for the subscription, that's very relevant. If you're building a serious game, that's funny, then you want that kind of programming language functionality to be there, right? You don't want it to be just like some simple, like, I don't know. My point is just like Lua is kind of a little bit too simple once you start getting into like having lots of files, like thousands of lines of code or whatever. Once you have a huge game, it becomes really difficult. It doesn't scale particularly well, in my opinion. And there was a lot of challenges at EA to do with Lua and to do with like just a lot of stuff, right? Because like, for example, one of the games that we shipped, Need for Speed No Limits, like their whole UI and metagame and everything was written in Lua. And for a metagame, like it might be okay, depends on the scale of it, but like it was difficult, I think. Like, I don't know how many people, I didn't really talk to the team directly too much about Lua, but I think that like the best thing that Lua has going for it is that it's fast. But from like a usability point of view, right? C#'s also fast, so it has that benefit. At least these two are, as far as I understand, much faster than Python. But it's just a lot nicer to work with on larger sets. But anyway, we're getting a little bit too sidetracked. I think basically just my point here, really, is that it's important to just note that scripting is something that is designed to control the engine, even though we might do so much of our own functionality and programming and all of that stuff, right? Inside that scripting language, right? But the main point is we want to control engine systems. And so because we're doing that, right, using something like Invoke, just to me, it just doesn't make any sense. Because first of all, as Peter actually pointed out in chat a bit earlier, it's not like there's a performance overhead to it, right? It's not the same as just calling a function in C#. So that could potentially be a little bit of a problem, considering again our primary use case is what? Controlling the engine. The other thing though is that, again, because like I've drawn this diagram for a reason, and it's all going to come back here in a minute, but because Hazel is kind of this ocean of stuff and scripting is a system in Hazel, for me it makes more sense for the C# to basically just be kind of embedded into Hazel, right? Like at the end of the day, like what I would like is for, and that's why we're using Mono at this stage, and also why we're trying to do things this way, is because the actual C# runtime, that is something that I think should be like ultimately hosted and controlled by Hazel. Like scripting lives inside the engine ultimately, because the engine is the world, the universe, right, in which all these systems lie. And so that's why, like, the way that we're going to be interfacing with all this, instead of doing some kind of Invoke, is if we're trying to load some other thing, like we shouldn't have to load anything because we're inside it, aren't we? Right? So why are we trying to load some other DLL full of stuff? Like that does not make any sense. So instead what we do is we use a little feature called internal call. Now what is this? An internal call, now I don't know if this is the formal definition, but what an internal call is ultimately is basically a way for you to provide the C# runtime, the C# engine that is running C# from C++, obviously, right? Because like C# you could say is written kind of in C++, even though a lot of it's written in C# as well. But like if you talk about the virtual machine that is running in C#, that's running in C++. And so what you can do is you can provide it with a native function. And so you're basically saying, hey, C# runtime, here is an additional C++ function for you to utilize. And that is basically the story of how we are going to set all of this stuff up. When we call any kind of C++ functions from here, instead of using something like Invoke, what we're going to do is we're going to tell the C# runtime that is hosted inside Hazel, we're going to tell it that, hey, here is a native function that you can call. So it's almost like we're adding a function like to the library, right? Like that might not make sense because a lot of C# library is written in C#, but it's almost like we're adding a native function to C#. That's, I guess the word I'm looking for is intrinsic. It's almost like we're adding an intrinsic function to the actual like compiler in C++, right? But it's translated into like a virtual machine and C#. That's ultimately what we're doing. And it's very, very easy to do. Very easy to do. And marshalling data is also rather easy between the two, which is fantastic. Marshalling data, by the way, those of you who are unaware, just refers to any kind of transformation of data that has to happen when you go between two contexts. So when you're going between like C++ and C# or C# and C++, there may need to be some data transformation that takes place. Why? Well, because C# is a managed language. And since C# is a managed language, it has concepts such as garbage collection. Like if you look at a string, for example, in C#, like that's obviously like a C# class, right? I just hit F12, so it'll come up here. So string is it's a class, right? It's a class which implements all these interfaces. It's like an actual kind of C# managed object. And so you need to ultimately like create a new string instance. You can't just like take your std string or const char pointer and be like, yeah, here you go. I mean, I guess you can. You could probably take it in as a pointer of some sort inside C#, maybe inside like some kind of unsafe block. I don't know exactly how that works. We don't really do that, but you probably want to construct like a C# string out of it. And so because of that, and same for like vice versa. If I have like, you know, I've got this string here, maybe I don't want to use console writeline. Maybe I want to use a Hazel like logging function that will actually log natively or like do whatever, right? I just want to send a string to C++. Well, a string in C# is this whole object. Right, so how do we convert that into like maybe a const char pointer or an std string kind of on the C++ side, right? So marshalling is kind of important. Manage v C++. So there's also this language called C++ CLI. I think this is a Microsoft thing. Stop that. So C++ CLI is something we're probably not going to talk about today, but this is a very interesting intermediate language kind of between C++ and C#. We used this at EA extensively. This is how Frostbite basically works. Now, not obviously the runtime, but the like all of the tools. Because what you guys might not know is that EA uses, because EA is, I don't really want to get into this too much either. I'm getting there's a lot of tangents here, but I guess I started, so I'll be quick. Basically, EA, because their like engine, Frostbite, is proprietary, they don't have to care about a lot of things that like Unreal Engine and Unity have to care about, namely platform support. Right? First of all, I think if you're making video games, you should be on Windows. Like that's just that. Why? Because 96 or 7% of people play video games on Windows. Right? And I'm talking about across desktop platforms. Obviously, a lot of people play on consoles, and you know, mobile gaming is a big thing as well, right? But guess what? All the consoles, like, you know, Sony, PlayStation, and Xbox and all that stuff. I mean, Xbox is Microsoft, so hey, Windows there. But also Sony make tools primarily for Visual Studio, so that you can, of course, they've expanded a bit, but in general, it used to always be Visual Studio. You get a plugin for Visual Studio that lets you debug and run code on a PlayStation. That's just how it works, right? Because everyone. And they have their own SDK and a lot of other tools, obviously, so you don't have to use Visual Studio, but I'm just making a point here that Visual Studio is basically the workflow, right? And that's the kind of the big thing. So you in general, and same with like Android and iOS. iOS is a bit of a different story. That's why a lot of people in our studio at EA had an iMac on their desk as well as a Windows computer, but just so that we could build an Xcode and deploy like to iOS. So that's a little bit of a special case as well. But in general, right, where was I going with this? Yeah, but in general, because Frostbite and EA and all that stuff, they have their own ecosystem. It's all proprietary. They can just be like, no. You want to build Battlefield? You want to build a map in Battlefield and you're on the team? You're using Windows. And so Frostbite uses Windows only. And Frostbite only runs on Windows. Like the editor, I mean, all of the tools. And so basically the way that because we have that kind of luxury of just being like Windows only, we can use native technologies such as WPF, Windows Presentation Foundation, which is basically, I know Visual Studio is written like in WPF as an example. A lot of Windows applications are written in WPF. It's like a combination of XAML and C#, XAML being kind of like an XML language, right? So basically what that means is that FrostEd, the Frostbite editor, is written inside. So FrostEd is written in C#, right? But obviously it has to interact with Frostbite, the main runtime, so it can render and you know, play the game. Obviously that's written in C++. So the way that EA do it is they use a language called C++ CLI. Right? That's an intermediate kind of language between the two, and you can basically kind of wrap your way into that. I don't know if that's still the case, but that definitely was the case at some point, right? So I haven't worked at EA for 3 years, so I have no idea what they do these days. But from my experience, that's kind of how it worked. And we also use this for our mobile engine, Osiris. So that's what C++ CLI is. That's also another way, another very valid way of running C++ code and interacting with C++ code from C#, because this is a cool language that in which you basically get C++, but it's managed, and so you can have keywords like GC new, and you have these hats which refer to like kind of pointers, but they're garbage collected pointers. They're like thingy, what are they called? I don't know exactly what they're called, but basically they're kind of like these garbage collection references, or like just managed references or whatever. I don't really remember. I haven't written that language in a while. But yeah, it's kind of cool, right? Yeah, handles. I guess handles maybe is what I was recalling from memory. So that's also a valid way, right, of doing that. And actually, that's also a system that I recreated for Sparky. So Sparky was an engine that I made a while ago, 6-7 years ago. And you can see there's this sandbox CS, which is actually written in C#. I completely forgot about this. And you can see it kind of does window equals new window, right? And it uses Sparky CLI. And if we go back, I think we have Sparky CLI. And actually this, I believe, is, so if we go to platform windows, Win32 application, is that what I want? No, I was looking for that window class. Yeah, so you can see that this, I believe, is actually written in C++ CLI. Yeah, so you have public ref class, which I mean is like a managed class here. There's your little hat, right? So you have like CLI stuff. C++ CLI is basically the language that this is in, right? And then you can see it essentially acts as a wrapper. So when you build this kind of C++ CLI DLL, then it becomes basically a kind of managed DLL that you can just add as a reference to your C# project, and suddenly you use it as any other C# DLL. But it's written in a language where you can also add a C++ like DLL or static library, maybe, I don't remember, as a reference. And then you can see you can literally use pointers and use, well, this stuff was written inside C++, right? So you get like a language where you can kind of communicate between the two, which is pretty cool. But again, I believe it's Windows only. But yeah, it's really cool. That's a bit of a blast from the past. But yeah, someone in chat mentioned C++ CLI or something like that, or managed C++. So we got into that debate. But it's also a valid language where you can just write, like the cool thing about that language, I guess, is that you can kind of write code that functions a lot like C#, but syntactically it's very similar to C++, and it is in fact native in the sense that you can just run native code normally. You don't have to like, you don't have to like invoke it or do internal calls or anything like that. It's just available to you. So it's kind of cool. It's almost like, yeah, if you wanted C++, it's the holy grail. Exactly. If you wanted like C++, but you're like, but I also want this object to be garbage collected, then you can actually do something like that, which is kind of cool. Maybe I'll make a video about that at some point. That sounds somewhat fun. Tricky boy, hey Jan, just want to say you have been the most impactful programming teacher I've had in my life because you delve into everything in depth. Thanks for everything. Keep doing what you do. God bless. Thank you, Tricky boy. Appreciate the kind words. So kind. I'm glad that I was able to help some of you out there. C++ with the GC. Yeah, it's a wild world, isn't it? Okay. Anyway, let's get back into this. Even though we could just talk about stuff for the rest of the stream. So basically, that's our strat for today. Let's Control-Z everything back into this, because this is what I wanted to write. Internal calls. Am I right? Yep. So basically what we want to do is basically add like an internal call into Mono that is titled something, and it contains certain parameters, and then we should be able to just call it. So how do we do that? Well, Peter, you are going to say nothing. I'm banning you. Actually, can I time you out? That would be funny for like 5 minutes because I want to figure this out on my own. Killian, thank you for the Prime sub. Appreciate the support. I won't time you out, Peter, but that would be funny. Just banned. Because I was thinking in my head, I'm like, I'm going to ban you from speaking, but then I'm like, I can literally ban you from speaking. Don't tell me anything. I want to figure this out. Because basically what ends up happening is I start writing some code that's like 80% correct, maybe. And then Peter's like, this is the code. And then I'm like, oh, sweet. But most of you guys who are following along with this series probably don't have, you know, a little backseat programmer who knows everything about what you're working on. Yeah, in fact, Peter, you can answer all of the why Mono and not .NET Core messages that I've been getting for like the past week from everyone, including emails, which I can forward to you. But yeah, because we've talked about this before, and again, .NET Core, like we might eventually switch to this in the future, but ultimately it's just because Mono is a little bit more suited for embedding at this current state. And there's also no real downside to like using it at the, like for now, right? Eventually, I imagine, as the years go on, we will probably switch to like, you know, Core CLR or whatever. Yeah, whatever the formal name is. But Peter can answer all those questions. All right, so, but for now we're using Mono because it's great. We should, you know what? We have obviously docs.hazelengine.com. Oh, actually, Peter, you've got your own guide. We've got docs.hazelengine.com, which has like some stuff. Right, so we have a scripting section. Maybe you can add a page to here, Peter. And you could also probably add a page to your guide. And then that way we can just link people to your explanation. Just because there's, or like have like a frequently asked questions as well. That's probably reasonable. Greetings from Wargaming Sydney. Greetings to you too. Free speech for Sweden, that's funny. All right, so what do we do? Well, the function we want to call, and I remember this because I wrote the initial C# implementation in Hazel and we did use internal calls, is basically mono add internal call. Now, I was thinking that this would have to take in some kind of like root domain or whatever, but apparently this doesn't. So is it really that easy? So there's a name and there's a method, and I have no idea what name is. Oh yes, I do. Hold on. So method is the signature, and name, I believe, is the name is just like the name. So like that, the name would just be CPP function, but the signature I think is a bit more. Oh, no, sorry. Const void pointer. That's the C++ thing. So what is it? It's just that. So what? Hazel.cpp function. The const void pointer here is actually going to be a C++ function pointer, I believe. So if I do something like this, right? Can it be like something like that? Maybe not. More than one conversion. I never really tried it with Lambda. But let's kind of work this out as if we didn't know what we're doing. And that's why I didn't want Peter to say anything. So embedding mono, this is a guide, right? So you have hello, mono add internal call. So you can see hello sample. Oh, okay. Yeah, that's right. You have to use this, not dots. I remember. And you can see that, well, this is a DLL import, which is not exactly what we want. Oh, this is the pinvoke method maybe. And then, yeah, and then we just do that sample and then sample. So do they have a sample? Yes. So static monostring sample, and then they've done that. Well, yeah. So you can see what they've done. They've just called mono add internal call. They have basically the fully qualified name of the C# function, and then a void pointer to a C++ function. And you can see this example even shows you how to create a brand new mono, because you can see this returns a string, and this is in C#. So therefore, if you want this to work, you need to make sure that you convert your string from, you know, C++ into a mono string, which in turn will give you a C# string. So that's pretty cool. Okay. So, with that example in mind, that means, I don't know if we'll deal with lambdas here, but let's just write a function here called static void cpp func, right? And we'll just have it do something like, this is written in C++. And then cpp func is going to be what we basically just add here, right? So this is a function pointer now, because we're not obviously calling the function. We're just providing the name of it, so it's a function pointer. And then here, if we want this to work, then we have namespace Hazel, and then inside here, we obviously need to set up something like this. And we'll just copy their example here. I'll close this page for now. And we'll chuck it anywhere. I like chucking it at the bottom, but it doesn't really matter. And we'll just say, with this, so control period or Control dot or Alt Enter, I think works as well for this IntelliSense style thing. So we'll just add the using system runtime compiler services, which will add this. And then we'll just dress this up to be CPP function, right? We'll make it return void. So it's just a little function that's an internal call. We call it when we call print int. And then, yeah, we've just added it as an internal call. I'm assuming you have to do this maybe, I don't know how this works. Maybe Peter can kind of help us out here. Peter, you're allowed to just answer this one question, which is what is the context of this? Like, is this per domain? Is this like once, or just for the entire like JIT thing? Like, how does this work exactly? It's per domain. Okay, cool. Right. So I guess you set domain, and that's like setting the context. And then this applies to the context you've set as like your global context. That's what I'm assuming. Which might be important later. But does that mean, Peter, that when you reload a DLL, oh, okay, right, but we don't reload Hazel DLL, do we? If you were to reload this DLL and make a new app domain or whatever, then I guess you'd have to re-add all of the internal calls, is that right? And then does that apply, my second question is, does that apply to Hazel, to big version of Hazel, because we obviously have two DLLs. We have script core and then we have the actual app. Okay, so we do that in Hazel to some degree. But I guess the whole app domain gets unloaded, right? Or do we have a separate domain per DLL? We'll get more into architecture later, by the way, stream. Peter's just saying yes a lot. Okay, sure. Oh, no, he said no. Okay, I don't know what he answers. Like, I don't remember the I don't remember the order of my questions, so that's awkward. But anyway, good chat. No, I think I get it. Okay. So we don't have a separate domain, which means that, yeah, we need to kind of reload them or whatever. Okay, cool. So basically, if my calculations are correct, this should now work. And when we actually call this print int, well, actually, let's call this CPP function from the constructor. That might make more sense. So after we see main constructor, we should see this is written in C++ get printed. So let me just add back that assert so that we pause. We didn't pause. Why didn't we pause? Oh, we're in release mode. So no asserts. But, oh, and it didn't call that. Okay, so we need to rebuild our script core DLL, which we didn't do, right? That's important. I might even add this as like a dependency to Hazelnut or to Hazel, because that way it'll just build it every time. Otherwise, I'll probably forget, like I did this time. But now that I've built it, oh, okay, that did not work. Mono runtime and class libraries are out of sync. So it just, well, basically it just can't resolve the internal call. So hazel.main, okay, so I didn't make that static, I think. I did make it static. Oh, but it's inside main. Okay, so I guess that means, now the other thing is though, right? So hazel.main, so you can see the function, this thing is only used for, because it's coming back to me now. This kind of C++ namespace operator thing is only used for the function, but the namespaces are resolved with a dot. That's also important, because if you obviously look at this, right, you can see up here actually, I don't know if this is Visual Assist or Visual Studio, but basically up here it's saying hazel.main.cpp function, and we can see that this CPP function, the fully qualified name, would be a CPP function, which is inside main, which is inside Hazel, right? It's not just inside Hazel, because it's not out here, which you can't really do in C#, but it's inside the main class. So what that means is that this becomes hazel.main, and then like this. Now you can see the actual thing that printed here seems to tell us what's going on. Now, I'm not sure where this came from. I think this came from, yes, I'm almost certain this would have come from the C# code. I think, maybe. Because otherwise, obviously, we didn't type in hazel.main.cpp function. We just had hazel cpp function. So it probably saw this and it was like, whoa, man, I don't know where that is. So that's probably what happened. Let's run it again. And there you go. You can see it works. So this is written in C++. We called this, which we wrote inside C++, but we called it, obviously, from C#. Very cool. Now, let's add something else. Native log, which is going to take in a string. So string, text, int, parameter. I want this to take in two little things. It's going to take in a string, and it's going to take in a parameter, and we're going to call native log over here. We're going to say, quick, somebody say something in chat. Somebody say their name in chat, and whoever says it first. I was going to use who's Snoopy, but Peter like just writes his full name. That's funny. I'm gonna say astrophysic because I think you were the first person to respond. We said mum. Okay, astrophysic. There you go. You won. And then we're gonna say like that. 800. 8058. There you go. So there's your native log with string text and parameter. We'll build this DLL. Then we'll go back. And now what I want to do is obviously do the same thing. Now the cool thing about this again, so we don't have CPP function anymore. We just deleted it. We renamed it to native log. So we'll take this in. Guys, I'm going to just let you soak in how easy this is. There's not even there's no signature here. It's just like the name. Right? You don't have to be like, oh yeah, by the way, it's like a string and you know, whatever, it's in it. No, it just works. Like magic. How cool is that? And you can call it anything you want. We'll call it native log, right? Now, what do we take in? Do we take in an std string? No, because we have to marshal this, right? So we take in a mono string, which is going to be our string. That's what this string is going to be passed as. And then we just take in our int normally. That's just it, man. You just take the int in normally, which we'll call the same thing. It doesn't need to be called the same thing, but we will. All right, so once you get this, you have a mono string. You obviously want to convert that mono string pointer to an actual like C++ string of some sort. So what we do is we call a function called mono like string to UTF-8, right? Which takes in a mono string object and returns a char pointer for us. So that's our string, which we can obviously convert into like a C++ string if we want, right? So I'll call this C string and I'll call this string. And then obviously, yeah, we can just do C string. I think this will be like a null terminated one. So there you go. There's your string in any format you want. And then the parameter. So now what we'll do is we'll just log a string or C string. Doesn't really matter. I'm just showing you guys what we can do, right? And then we log, I'll just add like a comma and a space, and then the parameter, and then maybe an end line. All right. So this CPP function becomes native log, and then I guess we'll just hit F5, see what happens. There it is. I couldn't find it for a while. Astrophysic and 8058. See, isn't it great? This is why Mono is nice, right? I mean, there's a lot of other stuff and Mono might be not so nice a bit later on, but for now, it's really easy to get started. And that's, yeah. I mean, I don't know if like, I remember I briefly looked at like, kind of, you know, core, .NET Core or whatever a while ago, like a year ago or something, and it was rough. You know, this was actually really nice. So that's how it works. That's like a basic example with strings. Now, there's a lot of other stuff we could talk about. Right? Like we can talk about, there's obviously a lot of data types we might want to pass. And actually one of the ones that I want to show you guys is actually going to be a custom struct type, because that'll come up quite a bit, right? You know, we can also talk like there's also arrays that we need to deal with at some point. Like you might want to pass an array of data between C++ and C# that requires like some marshalling effectively. But what I'll show you guys today, the final thing I'll show you today before we get back into actually making this do something now that we've got this ability to call C# functions and also to call C++ functions, we can actually start building up the API. I mean, we're almost done with scripting. Like, can you believe it? Obviously, Mark 1, but like if you're talking about minimum viable product, this is actually enough. Like, I don't know if I'm missing stuff. We're gonna do some more advanced stuff a bit later on for sure. And we're gonna work to make it a little bit more efficient, but I don't want to do any of that until we see this up and running and we can actually maybe even measure the performance of this. Because that way, when we make changes to the efficiency, first of all, we can be sure that they're the correct changes and that we're actually seeing an improvement and we're not just, you know, effectively just, you know, being like, oh yeah, good work me, I made it faster without actually seeing any numbers, because that's useless. But also because this is the simple way and it might be good enough for a lot of people and we may not need to make it faster. So yeah, so we'll definitely cover a lot of stuff, don't worry. I feel like I always need to cover my back when I choose to do things the simple, naive way. But that's the fun of programming. Like, you should iterate over your stuff, right? And you should make sure that you have some kind of workable baseline. It's better to have something that works. You know, unless you're going to end up undoing a lot of work you've done knowingly, like that's a bit silly, but we're not, that's not going to be the case, because we can build up our entire C# API, right? And actually even make a game without worrying too much about the back end, which we can replace later, right? Okay. Cool. So, oh, do we have to release this string later? I guess I am leaking memory, aren't I? Is there like a free? REE. Oh, free, mono free, and then C string, right? Yeah. So, for those of you playing along, thanks Peter for that, because I didn't even consider that, to be honest. So mono string to UTF-8 obviously gives us back a char pointer, and in order to actually get that from a managed language like C#, there needs to be some kind of way of, you know, copying essentially the characters from C# into something that's stored in memory in C++. And it does that by you know, allocating presumably some kind of block of memory to house these characters inside the string. That's the pointer to what we get back, because we're not getting back a std string, which could be destroyed automatically, right? Because that's like a wrapper for a pointer for a raw allocation. This is the raw allocation, so we need to make sure that we've freed it. Now this line of code here will copy this data into here, so it's valid. It's fine to do this, and then you can do that, right? So, I'm assuming, I'm just going to double check, but I think so. Yeah, so that's fine. And you can see Hazel's running. Everything's great. And we get our thing. All right. So, what's next? Yeah, I wanted to show you guys how to get structs and stuff. So one thing that might be important, right, is math types, obviously, right? So we might have a struct. I'll just write it up here, called like public struct vector 3. And this struct is going to have like an X, a Y, and a Z float, essentially, right? So when you have something like this, and you can, you know, write a constructor for this. Now we don't want this to be, there's a big reason why this is a struct and not a class. Those of you not too familiar with C#, there is actually a difference between class and struct. It's not like C++. Basically, a struct in C# is stack allocated, and a class is heap allocated, you know, plus like GC obviously and all of that stuff, right? It's like a real heap allocation. And because of that, you can imagine when we're dealing with math especially, we're constantly just making vectors all over the place, right? because it's just a math type. Like in C++, you're probably used to being like, you know, GLM, vec3, like just all the time. You're adding them together, you're creating temporaries, you're doing all of this stuff, right? Well, we want to be able to do the same thing in C#. We want to just be able to be like position equals like that plus that, or, you know, make like a quick little new vector out of it or whatever. We're doing this stuff constantly inside like the onUpdate function potentially. We don't want this new to constantly be allocating heap memory, because that's going to that's just going to be slow. So instead, we basically, you know, make it stack allocated and use a value type instead of like a reference type. It also means that when you pass these into functions, they get copied as well. So there is an important kind of distinction here, okay? It means that there are some limitations to how we use them, right? So if you kind of like copy this, I don't know if there's a good example here now, but there are some cases in which, because it gets copied and not referenced, if you have this inside another class, like inside a transform class, you can't just be like transform.position.x or whatever equals something, because you have to copy it into the current stack frame, do the change, and then kind of add it back in. That's why you see a lot of, in Unity, like you might see a lot of like position equals like transform.position or whatever it is in Unity. Probably looks like this, and then you set like position.x to something, and then you set that back to that, right? And that's just because it's a value type and it's not a reference type, and so you maybe have to copy it, modify it, set it back, stuff like that, right? But yes, there is a way to pass structs by ref. You just use the word ref, right? We actually use that all the time, and we're going to use that here as well. So anyway, we have this beautiful class, or this beautiful struct, rather. It's a vector3. So what I'm going to do is I'm going to fill it with data 521 like I did here, and then I'm going to call native log, so a different overload of the same function, right? That's going to actually take in this position and print it. Now you can see I've taken it in as a ref, and the reason why is because I want to effectively take it in as a pointer. And then I'm just going to be able to read it as a pointer in C++ and use it, well, however I like. So this is going to be like, this is going to take in a ref vector3, ref vector3, you know, parameter. And if I go back to our C++ code, we're going to do native log, and then guess what we're going to do? We're actually going to just take in a GLM vec3. Why? Because the memory layout is going to be the same. It also has 3 floats. We could declare some kind of struct vector3 here that also had like float xyz, but because a GLM vec3 is the same memory layout, asterisk, then it's going to be fine. And that's obviously not really called string. We'll call it parameter. Right? Now the reason why I said asterisk is because, believe it or not, I mean this is actually pretty believable. It's not that far out, but a vector3 in GLM might actually be 16 bytes. It depends. If you force SSC to be used and SIMD and all of that stuff, these types will be 16 bytes, right? And if you do a size of, you'll get a 16. That's important to consider, right? In our case, we're not forcing any SSC, because like GLM, depending on how much you dig deep into GLM, like you'll see that they have some actual like SIMD types here. And there's actually a define that you can use if you want to force them, right? So these are just, I don't know if it's worth showing these, but the reason why I started talking about this even was mostly just because of the fact that, maybe it was in here. The fact that it's just important to be aware. It's really important to be aware of the memory layout of your types when you're marshalling them between C++ and C#, right? So I just want you guys to just be aware of that. Now, there is, I'm trying to find it. Yeah, well, They had a page on GitHub, I remember I read a while ago. But basically, there is this, you can force this by using GLM like force SSE2 or force AVX, right? And then you can get the kind of SIMD support. But if you do that again, it will expand your types. So just be aware. That's important because the size of these types and the way you pack them might be important. So for example, for like a vertex buffer, if you're packing your vertex buffers and you're not aligning the types, which you really shouldn't be, you should be packing them as tightly as you can. Then obviously the vec3 becomes a vec4, and that might mean that you can't really use size of vec3 and like stream the whole thing in, because that's now 16 bytes. And anyway, just a heads up to be aware of like how big stuff is. But basically we can take this in. We're not going to use any of this, obviously. We're just going to take this and we're going to print it. Now, I believe Hazel has some logging functions for like this stuff, right? So there is a glm2 string that I believe will work for any vector and matrix and all that stuff. So that means that we could, I don't know why we're using this stuff. We could just use Hazel logging functions. So let's use like hz core warn, we'll say. And we'll just take in, we'll obviously dereference it, but we'll take in that parameter there, and I might just be like, you know, value, and then, you know, whatever. Like that, right? So that's our native log, calling that. We'll make it fire from the constructor over here. So we'll call that with ref position, which is 521, and hopefully we'll get that result back. Let's just make this like 2.5 or something, so we're sure it's a float. Not that it matters too much. We'll build the DLL, and if I come back here, we need to also make this happen. Now, this brings me to the point of how on earth do we make overloads happen? Which, by the way, Peter, I was hoping you could answer, because I don't know. How do we make overloads happen, or do we actually have to call them something else? But it's not a big deal to call them something else, because you can obviously wrap them as well. But yeah. So you could have like some kind of, if you can't make overloads happen or whatever, maybe you can, but it's not easy. You can obviously do something like that and then have something else that has overloads in C# and calls the appropriate one. I think you can provide the signature to add it to internal call. Okay, cool. So this is a bit of a test that has that might require some documentation. I don't see any. Oh, you can. Yeah, I think you can. Oof. But what's the vector 3 gonna be? Because that's just like a ref vector 3 or whatever. Yeah, that's gonna be tough. And then obviously this part you could actually get the type of this, right, and cast it to the type. I'm assuming that might work. Because how am I gonna point to the right function pointer as well? I'd have to make sure that I'm, you know, I might have to type def it and whatever. It's probably not worth the trouble, to be completely honest. I think I'll just do native log vector 3 like I did here, native log vector. And then obviously, by the way, as an example, this is what I'm talking about. So you can make like a log class, or just log instead of native log. And then you take in string text in parameter, right? And then that would obviously call native log with text and parameter. And meanwhile, I don't know what happened to my other curly bracket. And then meanwhile, you have an overload of log that just takes in vector 3 like normally if you want. If you don't want to, you can make it a ref as well. And then this just does ref parameter, and obviously with the vector version, right? And then from here, obviously now it doesn't matter. You just call log and you just call log, and this isn't even a ref, and everything looks a bit better, right? So you can just wrap it up like that. And I imagine that it'll get like inlined and sorted out correctly, and everything will be fine. So don't worry too much about overhead. Native log vector, and then you'll also make a vector version just to make this a bit easier to understand. And there you go. You can be all like C style with it, meaning there are no overloads. All right. Cool. So let's run that, I guess. So now in the constructor, we should hopefully get that printing as well in yellow text, I believe, because it's a warning. Yeah, and there you go. Right. So there's your Hazel value, vec3, and then 5, 2.5, and 1. So that's an example of us kind of marshalling, I guess, a struct, which is pretty cool because this is an entire struct of data, right? X, Y, Z, and we're just sending it in as like a ref, and we're interpreting it inside Hazel as a GLM vec3 pointer. And it's already like a GLM vec3, we can do whatever we want with it. I guess one thing we haven't talked about is like, for example, how we would maybe return that. I don't know if that's worth it, but I guess how would we then take in a vec3 back? So we could return a vec3 here. Let's just do something like GLM, let's just like square, that'll give us a float, I guess. Let's do a cross. What's gonna be this cross itself? I don't even know. What happens if you cross a vector with itself? Because you don't get anything perpendicular to it. Is 0. Yeah, that's not what I wanted. Let's do... Yeah, you get a 0 vector. That's useless. I've never ran across a situation when I've had to cross a vector with itself, I guess, because that's silly. But yeah, I guess the division just gives you 0 or whatever. Flip a dimension and then cross. Yeah, okay, sure. So we'll do parameter, and then we'll do GLM vec3 parameter dot x, parameter y, and then we'll do negative parameter dot z. That's a good idea. And then we'll return that, right? Okay, but will we? Now, this is where stuff gets really, really annoying, actually. And it's important to talk about this. This needs a pointer, right? So how does that work? Because the real big problem here, right, is if we return a vec3 like this, we obviously can't just kind of copy it because that data, that's not really how things work, right? Like if it's well, I don't know, maybe there is a way to just natively copy it like this, but ultimately we kind of want to provide a pointer to it the same way we did that here. But we obviously can't like, you know, do something weird like, you know, result equals that and then give it that. That obviously doesn't make sense. I'm just demonstrating a point here. I know this is silly because obviously this vec3 memory lives within this scope. So when we return a pointer to this, as soon as we return it, it's invalid, right? But also we don't really want to do some kind of, you know, heap allocation where we do like a new GLM vec3 result or whatever like this, right? Because if we do that, then that's effectively that's memory that is allocated natively that then needs to be deleted. So what do we do if we want to return something like this? Well, the way that we do it is basically instead of taking this in like that, we make this still void and we actually make like an out parameter, which is our result. What that means is that the data, right, the memory allocation for this, the idea is we allocate it in C# already. So it's all garbage collected, the block of memory is allocated, it's ready to go, and then what are we trying to do? We're just trying to copy data into that pre-allocated existing memory block. So that way we don't need to do any like memory allocation, memory management, anything like that in C++. We just do it in C#. Easy, and then it's handled by the garbage collector and everything's great. So the way that that works is obviously we get this result from here, and then we take it and into our result, we copy everything. Now you can do this in one step just by dereferencing this and doing that, obviously, right? Or you could do it one by one or whatever, but ultimately that's kind of what we do. We take that and we get that, right? We do our cross and we copy it into out result. So now if we go back, what does that look like here? Well, instead of ref, which I guess we could also use, we use out instead. Vector3 result, right? So out vector3 result. And now, see, this is also the benefit of wrapping it. You can make this return a vector3 for some reason, right? So log vector. You could make this return. I don't know if that's gonna fly. I mean, it's a different overload. Yeah, I guess that'll be fine. And then what you do is native log vector, and then you can actually do like out vector3 result, for example. I don't know if you can just return that immediately. That's gonna be weird, right? So then you just return result. right? Or obviously you could write this in a bit of a different way in C# if you wanted to. If it makes more sense to you, you can write it like this, where you kind of make like a vector 3 or whatever. I don't know if you necessarily have to initialize it or how that works. And then you just do out result, right? I guess you do have to initialize it, right? But it's nice to also write it kind of inline like that. It makes a variable in this scope, and you can see you can now use it. So we've constructed this and we've passed it directly into that function. And then obviously now we can, you know, do console.writeLine if we want with that vector 3. So we get our kind of resulting vector from that. And then we can do like, you know, result.x. Let's do result.x. Oops. Result y, result z. And yeah, so we're still printing that. Let's build this. F5. And there you go. Okay, so we're taking in 5, 2.51. And then I guess we're negating that, we're crossing it, and we get another vector that's -5, 10, and 0. Okay, and then we're printing that obviously from C#. So those look like reasonable values. So I'm presuming that it's fine what we're doing. Okay, so that's how it works. We could have also just normalized it. Actually, normalizing the vector and returning it probably would have been a little bit better, right? If we just did normalize. I don't know why I decided to cross it, because I was going to dot product it, and then I was like, obviously that's going to give us a float. That's boring. So instead, let's make it like return a vector. I'm like, oh, yeah, cross product, but normalizing it, yeah, it gives us that. So we get a unit vector now, and yeah, that looks more reasonable. And there you go, right? Now, obviously, if you did want to return something, then you can just make it a float. You don't have to do like, you know, float like this and have it an out. You can if you want to be consistent, or you could just return a float or a boolean or like whatever you want, right? That's totally valid as well. And then like, for example, we could do like a dot product here and then just return it. And like, for example, there is our, so we'll dot it with itself is what I meant. Right? So there you go. And then we get obviously like a float here that we can return. Let me just, so how do we add the internal call? I mean, you guys are probably getting it now. Probably stop explaining it, but we basically just do that. And then obviously in here, what do? We just do vector dot. So the important thing, obviously this name matches what you've written here in the string. That's the big matching thing that's important. But then this returns now a float, still takes in that parameter. It's called vector dot. And then we can just do console.writeLine, you know, vector dot. And again, we can wrap it in log like we did here if we want. But ultimately we do native log. Let's do like that, vector dot, and then just like result or position, maybe that initial one. And then obviously that, yeah, has to be a ref. And there you go. That's done. So we build this. Didn't compile because I put a backslash in accidentally. Whoops. F5 runs Hazel instead. And there you go. So now we have the dot product of these two, which I guess will be 32.25. All right. Why can you return a float and not a struct? To be honest, I'm not sure. Maybe it's fine to return a struct since it is a value-based thing. I'm not 100% sure though, because it is a type that does need to be created. You can return a struct, but it's more complicated because the struct requires proper marshalling. Well, yeah, that's kind of my suspicion as well. It like literally needs to be something that obviously gets created in C# as well. And it's like, it has some kind of more complex lifetime potentially. I don't know. Like, yeah, it's nicer to just do it this way, I think. Although I don't really remember what the alternative is if you actually really want to return it. All right, cool. So, that's basically all there is. Obviously, there are way more complex types that we might want to marshal, and we'll also have to eventually talk about how like lifetimes are going to work. Also, Zaxon1234, thanks for the sub. I don't think I said thank you. I don't remember. So that, yeah, there's going to be some like conversation that we have at some point about lifetimes and reference counting and a few other things, because obviously, like, if we were to do certain things in C#, so you can imagine, like, you know, for this kind of puppet string stuff, it's probably okay to just be like, engine do this, engine do that. Here's some data, you know, so that you can do what I tell you to, and that's fine. But if we start to kind of do things like, for example, create assets. So maybe I want to create a texture, right? And so if I create a texture like this in C#, you know, that is like 1024, 2024 RGBA or whatever, right? Then what this might need to do is obviously create some kind of asset, essentially create like a texture in like native memory. And so when that creates a texture in native memory, we get the question of like, how does lifetime work? So in other words, like, how exactly does, you know, because this texture, like, I need to obviously basically new this texture, right? I need to create it inside C++ as like a heap allocation, right? Even though it's, but its lifetime is kind of tied to this garbage collected version here. And I want this garbage collected version here to actually, you know, when this gets garbage collected, that means C# is done with it, which means I probably want the C++ version to release it, right? And then that comes down to just being able to, well, first of all, we just want to use reference counting in the engine in general, which we don't at the moment. We just use we do in Hazel, in Big Hazel, we have our own like reference counting class, and we have like a intrusive reference counting system that's very, very important. Right, but you can kind of achieve a similar thing initially with shared pointer. It's just you're probably going to want more functionality, hence the intrusive reference counting. But doing something like that is important, because it means like if you have an engine with potentially a render thread, then even if C# might be done with it and it might garbage collect it, you might not immediately want it to be deleted, because it could still be a valid resource that's in use by like your render thread or something. So you still want the data to stay alive, obviously. But then also, ultimately, it will just come down to writing a texture class in C#, having the constructor obviously perform the allocation, potentially store an int pointer. So in C# it would look like an int pointer, which is like a native pointer to that memory block that you allocated natively, if you want. And then in the finalizer for this class, which gets called by the garbage collector, you can call back into native code to do a C++ free. So in other words, you do like a delete or whatever inside C++ to free that memory, right? So that's how that system works. I'm just giving you guys a little bit of a heads up on that, in case you want to implement it yourselves, or if that might help you. But we will obviously deal with that, like when the time comes, because we want to be able to do that stuff. Yeah, that's basically it. What I want to do for the rest of today, so I've got like maybe half an hour or so left that I want to keep streaming for. So what I want to do with the rest of today is I want to start utilizing what we already have and start building up some kind of library. Right, so at the beginning, like this stuff's pretty good. Like, we have a great sandbox here of like a lot of examples, and that was kind of my goal initially. Like, I wanted to build this up so that we had like a reference, you know, of stuff that we know works. So basically, like, just to summarize, we obviously have the ability to initialize mono, create an app domain, load an assembly, right, and then you know, create instances of C# objects, call their constructors, and then retrieve and invoke certain functions from within that object, as well as also use C# to invoke native functions. So that's a summary of everything we've covered. And again, if you guys missed the last stream, then Cherno Unplugged is my second YouTube. Well, I have a lot of YouTube channels, but it's one of my YouTube channels where these streams are posted. And that's part of the Game Engine series. So the latest video on that channel is us doing this kind of initial work that we did last time, and a lot of explaining as well. So check that out if you're interested. But yeah, basically at this stage, it's obviously just about us using this stuff. And again, like my point here is there's a lot of, you know, simplicity to this. Like we have not done much at all. Like if we look at our actual mono code, there's what, like there's less than like there's like 50 lines or something. Like this is it, guys. This is the mono code we've written. I believe this is all of it. I mean, there's obviously not. Well, print assembly types doesn't really need to be called. Load C# assembly is important as well. That's some mono code as well. This is just a generic read bytes function, which we could probably move somewhere else, and we'll probably have to refactor a bit of this stuff. But essentially, that's kind of it. Like, there's really not much to this, and this is kind of enough to get a jump start on this, right? For reference, that'll probably be 1,000+ lines in core CLR. Yeah, that's also true, yeah. So Mono makes this kind of embedding thing really easy, which is why I think it's a really good choice. And also, back to this puppet string example, this is also important, right? At the end of the day, it's important to us to remember that we're using C# as a scripting language to pull these strings. And so because of that, it doesn't we don't necessarily care too much about like the latest C# features and like, oh, does it have this? How big is the library? Because yes, like that stuff is nice to have. I'm not disputing that. I'm not saying that, yeah, we don't care at all. I'm just saying that at the end of the day, we need to be able to use this to write some code that will do stuff in Hazel, right? And for that, it really doesn't matter too much what you're using, right? As long as like the performance is good enough, and good enough is very, very subjective. It might be, it might not be. That's why, in general, we of course aim for the best performance possible because that way more is possible. But that's an important consideration also to make sure that, like, you know, what's the like maintainability like and all of those other kind of important things that we should think about. All right, cool. So the first thing I want to do with this before we actually dive into C# and write a bit more code in C# is I want to be able to kind of separate this out into like a few different things, into a few different functions, and maybe design this a little bit better. I'm not going to go too heavy on the design for now, but basically what init mono is going to do is, importantly, it's going to set up a root domain, create an app domain, set the app domain, right? And then probably load the core kind of assembly. Now, loading the core assembly, init mono, like I think ultimately, Peter, like what we do obviously is when we, like Hazel script runtime, when we load the C#, when we load this assembly, when we reload this assembly, which we'll do later, this needs to be unloaded, doesn't it? So because of that, I probably want to tie kind of all of this stuff together. So what I want to do is I'm going to make a function here. Peter's saying yes. Called static void load assembly. Const std file system path file path. So we'll use just a we'll use the file system file path for now, and we'll make it a public function. So this now is going to do basically this. We'll grab those assembly types as well, but load assembly. Let's grab file path into here. We'll make that work in a minute. And init mono, and then what would I have copied here? This, yeah. So when we do init mono, we'll also do load assembly. We could call it like load core assembly or something, but basically what I want this to do is do the app domain. Add internal calls we can do later. And print assembly types we can leave as like a little debugging thing. And then so load C# assembly. So this, I'm gonna rename this to just be load mono assembly. And this will probably just remain like, might put it into namespace utils for now. And we'll just make this as a little static function. It's a little private function basically inside this class for now. I think that's probably reasonable. And then yes, this will take in a file path. And so read bytes is also something here. Do we have a function like read bytes inside inside this thing? I don't know if we've necessarily got like a file API. File dialogues. I mean, we're definitely reading stuff for the OpenGL shaders and whatever. Are we caching them and reading them? We might want to like make this a. Yeah, I don't think we are. Okay. So we might want to like file. No, there's nothing. I was gonna say we might want to have some kind of like file system, you know, file utils kind of class that lets us kind of obviously do this. So there's not, because there's no reason for this to be here. I don't know if I'll call it file system, but we'll make sure that's something that gets moved, I think. Because it's not, yeah. But basically this is, you can see, this is just generic, like this is just us reading on all the bytes here and allocating a new buffer for them. So utils load mono assembly. I don't know if that necessarily needs to be in utils. Utils I usually leave for like generic utilities, but this is clearly related to mono, so I don't know, we'll see. I'll also make this take in. I just wanted to take in file system paths everywhere instead of strings. And this obviously will also take in a file system path, so we don't have to do anything because the API is there for that. Okay, so this assembly path, let's say string. Okay, so this is where using this might be a problem because this needs a const char file name, right? Whereas this is not a const char file name. So what we can actually do is basically grab that string, so assembly path dot string, and then do string, say string. The reason that doesn't work natively like that is because file system path internally has wide strings instead of strings. And so we have to first convert the wide, but by calling string, you can see we get a string of chars here, right? Instead of just text, which is a wide string. And so because it does that, you can see it does a convert wide to, well, it calls this function, which converts our text, which is what's actually storing this, right? Which string type is wide, into like non-wide characters, into like UTF-8 or whatever, which is what this is. And then that's what we'll use here. So we won't call it string, we'll call it path string. And we can just do say string. Okay, cool. So apart from that little setback, I think that's pretty reasonable. I don't know if this should be configurable, maybe. I don't know. Just looking at various strings here. Alright, cool. So yeah, so we should be loading the assembly. Okay, cool. Okay, you guys in chat really have to stop capitalizing Lua. It's funny because you guys are talking about Lua, but you don't even know how it's written. Lua is not capitalized. Like everyone always, like, I don't know why people capitalize Lua. I really don't. Like I remember this being like a thing at EA as well. Like people would just be writing Lua like that and we're just like, oh guys, like, please. Like, please stop capitalizing Lua. It's written like this. Like, you know. Should we also write Python like this? Python. Alright, anyway, I should stop looking at chat though. Yeah, Worship the Sofa's got it right. That's what I meant. C++. I think capital L Lua is fine. Like, if you Google it, the best thing is Googling it and then looking at the logo and then looking at this and then looking at this and then looking at this, and then you can tell that it's, yeah. I mean, the logo has the L capitalized, so I think that's safe to say that's how you write it. C hashtag. All right. So where did I stop? So this is what happens when I look at chat. Hazel, that's funny. Silver Crawl. All right. Yeah, so load assembly. So it would be, yeah, that. I think that's shipped. That ship is sailed is what I meant when I said shipped. Okay, but we also need the assembly image, and what do we need that for? To get certain classes by name, right? So assembly image is probably something we also want to store. So this mono image assembly image, let's take that and let's pop it into load assembly. So once we have that, we can get the assembly image. And then when we come up here, let's just do core assembly image. Now we again may change this as we add more stuff here. I'll probably end up creating like separate structs for this, because we'll see that these two are usually grouped together, assembly and image, for example, because we're going to have an app assembly as well. So we'll refactor this a little bit to make it a bit better in the future. But for now, we'll keep it like this. So sdata assembly, core assembly image. Becomes assembly get image, so we no longer need to take that in here, and then this will be core assembly image. That's also obviously loading a class by name, which is fine to leave, I think. And then what? And then we do a new version of that. Okay, so this is kind of like retrieve and instantiate class with constructor. That's going to be call function. So call, I'll say call method, since it's like a class function. Or like a, yeah. And then this will be like call method with param. That's okay. We have a lot of examples here, don't we? Okay, but basically that's kind of it. So this stuff is obviously extra example stuff. I'll move this now outside of init mono, so init mono can stay kind of pure. And then we'll just move this into like basically here. So we have our internal calls. So this is what I want to basically say is going to be all of our types. Now, basically what we do inside Big Hazel is we have this class, which I think was called like script registry or something. But then lately, I think Peter renamed it to script glue. And this is kind of like the glue that joins C# and C++. So basically what this is going to be is a whole bunch of types that get registered into Mono. So script engine, obviously all of these mono add internal calls and all of these native log and all of this stuff, they're going to exist within script glue, right? And then we can just have a little like, I don't know, I guess I'll call it script glue. If like I'll make a class out of it, even though we don't really need to. And then register functions or whatever. I don't know what. Should I look up what it's called in Hazel? Maybe not. Then we just have register functions, and then what we do is we have, basically the point is all of these internal calls now are here, and then all of these things that we just had, like native log and all of this stuff, they're also effectively here. And in Hazel dev, or in like, well, in the big version of Hazel, this is just one huge file that has everything, right? And I really like doing that instead of trying to have like all of our C# stuff just, you know, segregated, you know, across the whole engine. It's just such a mess. It's just so much nicer to have it all in one place. Because then you just know like everything's in one place and it's great. And the reason why that's also so useful is because a lot of the times when you're implementing a function and you're trying to, like, maybe you've written a new class, or you've just written something else and you want to expose it to C#, then you need to look at references, right? You need to be like, well, how are we transferring strings? How are we marshalling arrays? What about a vector 3? How is that, you know, converted? How is that done? And so if stuff is like just all around the engine and you're like looking at like, oh, let's see, where's a good example of us like, you know, marshalling an array? Like that's a joke, you know? But this way you look and it's like, oh, look, there's functions all around me. There's like 10,000 lines in this file. You know, everything's like there. In fact, I'm going to try and find that. I think I can look at this. I'll show you guys like what I mean. Yeah, so like, so this is the script glue class, right? And then you can see there's even regions. Peter's like added little regions, so you can easily see like, you know, what you're looking for. And then if you go to the CPP file, you can see it's quite long. It's like it's like almost 6,000 lines of code. But when you look at it, the great thing is like you literally have, you know, everything that's exposed to C#, you have it all here. So like, again, if you're like looking for something and you're implementing something else, you can look at everything and it's all just here in one place in one file. So I love doing that, honestly. I think that's a really, really good way of doing things. Instead of like, just because I remember like one thing I think I did with Sparky maybe, or with something else is like, you know, we like a rigid body component is an actual component, for example. Let's go to like texture 2D set data, right? Which like copies data or whatever from an array in C# into here, right? Like I could have obviously gone to like the texture 2D class and then like inside, or the texture is still in one file here as well, and then implemented the C# stuff here. But that's just so like, I don't know, that's so annoying to me to want to like, you know, implement everything alongside the C++ code. The other reason why, guys, is because like obviously it depends, like if you're building this stuff in C++, like I'm not saying that C# wouldn't be, I think C# is a pretty mandatory module, but the cool thing with this as well is you could just not do this, right? If you're not using C# scripting, maybe you want to write your whole game in C++, you don't need any of this. Whereas here it's going to be a little bit annoying to, you'll also have to maybe surround it with macros so it doesn't get compiled, or have an additional like texture C#.h, and like, why are you doing that? Like, I'm really all for minimizing files when it comes to like how many files we want to deal with. So yeah, so we have kind of this instead, which just contains a lot of like, you know, C# kind of mono interfacing kind of code, as well as, you know, this, which is like us adding all of those internal calls over here. And then you can see this is like a macro, which just calls mono add internal call. And this way it kind of just, because we have a convention and we also have all these internal calls sitting inside an internal calls namespace, it just slightly reduces like the, you know, the like a typo or something by not really relying on a string, since this is actually a function. You still have to match the name exactly inside the C# code when you're writing it. That's also, by the way, where all the C# stuff lives. So internal calls.cs contains all of the C# stuff all in one file, all of those internal calls. So like, what were we looking at? We were looking at texture before. I was just trying to find it. Texture actually might be a bit of a different case, I was going to say. No, we still have the native calls here. So you can see all the internal calls, they're all just listed here, right? And then the reason for that is because, yeah, that way, like if we want to, and this is all inside like a internal calls kind of static class. And so that way, when we're like inside like the texture2d.cs class and we want to create a new texture, then we just call internal calls like, you know, whatever we need basically. So texture create in this case would actually create a new texture, and then call internal calls texture2d create, and then get like the asset handle for that from the engine, from the C++ engine, and then do like whatever, right? So yeah, just an example. But yeah. Okay, so that's kind of it. So what I want to do is I do kind of want to set a convention a little bit like this. Like I want to do like hz add internal call or something. I don't know what, let's see what Peter called it. I do want to somewhat be consistent between Big Hazel and Little Hazel. Oh, and there's also like components that need to get managed, thingied. Oh, by the way, Peter, this is, I don't know if you've noticed, but this is another example where you should not use a macro. You should make this a function. Because, yeah, like you can call that function with a stringified type if you need to, because you're obviously joining two strings here. But, yeah, I would make this a templated function instead. But in general, add internal call like this, yeah. This is kind of what I'm copying here. So it is called add internal call. And then I don't know about iCall being the name. Well, my call is like just, what is this really? This is like the function name. So I'll just say name. And then we'll do mono add internal call. Okay, so what we're going to do is we're going to also put it into, so remember how we used main here, because that was the name of our class. This kind of is going to become like a public static class internal calls, like it looked like in Big Hazel, right? So this effectively now is this, and then we have like the name of the function. So that means that we can basically copy this part, right? And then to this, with that, we add the stringified. We concatenate a stringified name because we also need a non-stringified name for the actual thing, right? So that's kind of important as well. So for that, we just call name like that. And that will be obviously this. So in other words, all I've done here with this little macro is I've just made my life a little bit easier because there's just a little bit less of a margin for error, where basically all it means is that instead of having to write out this whole thing, I just say add call native log, and that's it. And I expect there to be a function inside this hazel.internal calls class that is the same name. That's basically it. Now we used to have an underscore native thing, which you can also do if you just do underscore native. Basically, this was a thing that, I guess Peter removed this, but it used to be like everything that was native used to have an underscore native. And the reason for that really was because these used to actually all be in their relative C# class. But now that they've moved into just the internal calls class, obviously these are all native functions because they're in the internal calls class. So it makes less sense to have like an underscore native. But like, obviously you could just add that into the macro if you really wanted to or whatever. So yeah, so there it is. There's name. And that becomes that, right? So you guys can see that it just saves a little bit of space. And it's just one line, so it's like easy to debug and everything, and it's fine, right? But yeah. Okay, cool. So yeah, so that's kind of the story. I don't know, we might end it here, to be honest. Just because this seems like a natural place to end it. And then next time, why are you all upset? Did I miss something? I don't think so. Let's try build this. Wait, what? I mean, it's bringing that stuff up. Oh, incomplete type. I was gonna say it's bringing up some C# stuff, but that doesn't matter. Incomplete type. Oh, right, I haven't included mono. Might actually know. Just object, maybe? I don't know what needs to be included as far as mono goes. That seems good enough. All right, cool. Okay. All right, okay, cool. So that I think is decent. Yeah, so I think we'll kind of end this here. Like, I'll finish the refactoring, we'll end this here. I was going to start setting up C# properly, like with all of the stuff, but I think it's probably better next time. I think what we'll do, we'll save it for next time, and we'll just dive in with creating like just a script component that can link to something, and then we can actually set up an entity that we can control with C#. We'll do that next time. That'll be really exciting, I think. That way it'll be like a nice trilogy of getting up to that, because otherwise I think it's nice to maybe not make this episode hugely long, because I mainly wanted it to be about internal calls. Okay, so to finish this though, I still want to kind of have an API for this. And blah blah blah. So yeah, these are, I guess we should test this as well to make sure it's working. But let's include inside here, let's include script glue. And I just collapse these utilities. And then we'll do register functions like that. And then obviously like this stuff is us invoking stuff. Otherwise we invoke other stuff. So let's do, how are we going to split this up? Okay, so let's think about this, because this main at the moment, right, which I've kind of renamed into internal calls. So let's kind of keep this, let's do a couple things here. So we'll make this just be main, because I still want it to be main. But the difference is the internal calls will go into a different class here called internal calls. So this stuff gone, it goes into here. And then all this stuff that we want to call, we call like that, basically, right? Otherwise it stays the same. So we'll do internal calls, internal calls, internal calls. We'll make sure these are like public or internal, doesn't really matter. Internal just means internal to this assembly, which I guess is okay. Usually like we keep them like that in the Hazel script call, because we have an additional assembly for the app, which we will talk about eventually as well on this. I was gonna say on this podcast, I don't know why, on this in this like game engine series, obviously. Let's build this C# DLL. Okay, cool. That looks good. That looks probably good. I might just run this at the moment. So load assembly. Let's move load assembly down here. I don't know why it's up there. Print assembly types is kind of a utils thing as well. So let's move that into here. Again, it's a utils thing for now. We might not make it a utils thing when we realize it's actually important. But for now, it's like a utils thing. I just want to go back to where we were doing that in case we bring that back. In case people want to play around with that. Okay, that builds. Great. Okay, so yeah, so back up here then. The reason why, let's run this and make sure that we haven't broken anything. Yeah, that looks good. Yeah, we're still getting our dot product and everything. Astrophysics is still here. Cool. All right. So let's do this. So main is a good example. Like, think of this as if you're instantiating an entity, right? You've created an entity, it has a script, you want to make a new entity instance inside C#, right? So how does that work exactly? Well, you're probably going to want some kind of like way to create a new instance of a class like this and then call the constructor. So this happens obviously, like we retrieve it from some kind of assembly, that's important, and it also has a namespace and a name. That's also very important. But then we make a new instance of it based on what we've just retrieved. And then also we have to run this code to actually call the constructor. Now, what we do in Hazel with this specific thing, right, is we, we kind of can do this up front, because I don't know how much this costs, monoclass from name, like if it's an expensive function or not. But ultimately, like we probably don't want to be calling that, we definitely don't want to be calling that every time we instantiate a new entity, considering that's so common to do, right? So we can kind of just be like, you know what class is going to be really important to instantiate continuously every time we create a new entity, which is probably going to be very often during the runtime of a game. This one. So we can retrieve this stuff ahead of time, have this mono class kind of pointer, and then every time we want to instantiate like an entity, we just call this. So I think for now, because we're keeping things kind of simple, I want to actually set it up that way. So I'll say, basically, let's rename main to entity so that it really is an example of an entity, right? Let's build that. And then what I want to do is I'm going to make this thing here. We'll have a mono class, and I'll call this entity mono class. Nah, I guess I can just call it entity class. And then we'll set up sData entity class like that. And we can just load it in like that. Right? And then what I want to do is, should I put this back into utils? Maybe. Instantiate class. Mono class. But that kind of needs, I guess that needs an app domain. Yeah. I think what I'll do is I'll move this into here. The way I'm kind of deciding whether or not I put things into utils. It's annoying that I can't run a class, isn't it? I'll just do mono class. The way that I decide whether or not something gets put into utils or not is basically, does it use members, right? Does it use any class instance data? If it doesn't, it basically goes into utils, right? So print assembly types just needs this. That's all of the context it needs. It's fine. But you can see that this needs the sData like app domain. Like this isn't really the class instance stuff, because obviously you can see it's not here. There is no class instance data really, but it kind of is in the sense of like it uses sData. So it's not that this wouldn't work in here, right? But you can see this doesn't use sData, and neither does this. It's all kind of self-contained. If it's self-contained, it goes into utils. That's kind of my criteria at the moment. This stuff kind of goes into here though. Script engine instantiate class. Now I've just used a mono thing up here. So what we probably want to do is forward declare mono. Forward declare that thing, because we don't want to include mono here. It's a bit heavy. Now forward declaring mono though, I think there's a special thing we have to do. Yeah, because it's kind of in C, we kind of want to do basically this, I think, which is a little annoying. But we have to like type def it this way and use the extend C thing if we want to actually have that thing here. So that's how we can get a mono class into here. Again, I don't know if it's worth us doing this stuff here. Maybe not. Maybe we just don't want to do that. Yeah, we'll see. We'll see. But whatever, I think it's fine. We're going to do today something forward C# core library so we can later say, yeah, so we're not exactly going to do that today. We'll do that next time because I want to set up C# with entities next time. But everything I've shown you today should be enough for you to do that yourself if you figure it out. Like it's not, I've shown everything that you need to know. We're just physically not going to do it, that's all. So because I want to set it up deeper with the entity system. Okay, so instantiate class does that. Now obviously this gives us back a mono object though, which is important because that's our class instance. So we want that mono object back. So let's just duplicate this and also add that in here. We might actually put this into a different header file that we can just include so it's not all dirty looking like this. But yeah. So we'll do return instance. And that's how we instantiate a class now. So we've kind of gotten rid of that now. We're retrieving the thing, and then if we want to instantiate an entity, we simply do that, and we get our entity back. Now instantiate class. Why is that an error? Non-static. So we need to make that static. Okay, cool. And then we obviously get like a mono object instance back. Right? And then we can obviously use that instance everywhere. Now, if we want to get the thing back, you can see we also need the class though. So we invoke it on the instance, but we have to retrieve a method from the class. So this is where it becomes like a little bit of probably like it probably makes sense to make some kind of API basically. Right? So we want to have like maybe our own kind of script class or something, class, right? That, basically, we want to have our own kind of script class that basically lets us just be like, you know, hey, I want to create like a script class, and it's going to be Hazel entity, and then inside that script class, I want to like get, you know, basically like an object-oriented kind of thing, where we can just be like get method, and then we'll get a name back. Like we'll just say that, and that way it already has this context inside it. And then we can even like just be like sc, you know, instantiate maybe. And then that would give us this back, right? So it would be probably pretty nice to have something like that, and that way we can just kind of have like this class up here that we can just use. I might actually make something like that. Let me quickly make something like that. So we'll just say script class. I don't know if I'll expose it like this. We might actually keep it inside here. Just because if there's no reason to expose it, I'd rather not. Because we might not use it anywhere else. Although, well, yeah, because at the moment this is all static. All the data's here anyway. But let's just do script class. We'll make it probably from the core assembly image, although maybe I want to take in the image that it's from. But basically, let's just do const scd string. We'll probably do a string view. Namespace. What does mono even take in? Just a const char. Yeah, we'll do that. Class name. Now I want to store these actually, because I want to store these because that'll be useful for debugging. And then what we'll do is we'll immediately retrieve this. Yeah. So that gets retrieved, and then that becomes, so basically this entity class is going to become a script class. So let's pop this up here. So this will be a script class instead, and it can just be a stack thing. I don't care. Well, I don't know. Maybe it shouldn't be. Maybe it should be, just because we might want it to get released at a certain point before Mono gets shut down. We'll see. So yeah, so this will be a mono class. I'll call it mono class. So it's a null pointer. That's that. And then, yeah, once we have this, the cool thing is we can add in some, oh, well, whatever. Just make a default constructor that does nothing. Okay, so yeah, so this becomes basically just script class Hazel entity. And then from this now, if we want to instantiate it, we're just going to do entity class, yeah, instantiate basically. So this I'll copy. Instantiate, so just a little bit more object-oriented. It's always nice to use object-oriented programming when you come into like a situation where you have a context and everything revolves around the context, right? So mono class is like our context, and a lot of stuff will revolve around that context. And so it's nice to just provide that context, store it like in a class instance, and then do like, you know, whatever you want with it basically, which is what we're doing here. So let's do mono object instantiate, and then that's just going to like return this, right? And then this obviously will be from that context, and it's going to be inside, I think, util, or maybe we didn't put it in utils actually. So instantiate class, oh, because it needs a particular domain. See, this is also where it's important. Like at the moment, we're coming from core assembly image, we're instantiating it based on a domain. Like there's kind of a lot of context kind of associated with it. So I almost want to kind of like, I mean, like this obviously still makes sense. We'll have to do like script engine instantiate class, and then we'll instantiate a particular class within that script engine. And I think that should be okay. It's I might just, I don't know if I want to keep it private, but we'll just, for now, we'll just add a friend class called script class, just so we can get access to that. And then, yeah, that looks pretty good because it makes sense for the script engine to do the actual instantiation, not this script class thing. But then you can obviously retrieve stuff like that as long as it's aware of this. But again, this comes from this in a way. Actually, we're not going to have access to this, are we? Because S data core assembly image is defined here. So that's not really going to build, is it? Yeah. Great. I mean, we could just obviously implement it later. This is annoying. Okay, no, I'm going to copy this. Maybe we'll define it down here. I'll keep it in the header file. That way it'll be easier to see the API that comes with it, I think. As well, mono class is up there, that's fine. And then, yeah, we'll keep the default. Okay. And then since we put that down, I'll put it here. Okay. Okay, S data entity class. Yeah, okay, so this stuff. So get method from name is another really big one that we kind of want to use, right? So get method from name will basically make something that's going to be like mono method get method that gives us back a method. And we might not need this. Like you could just cache this. Like we probably will do that. I just want to basically set it up as a series of utility functions for now. So we'll have like const scd string name and int parameter count, and then that's just going to return this. So let's see, so the class is just going to be mono class name c string and parameter count. Ooh, excuse me. Let's keep the constructors together like that. So this is obviously something we've just created. All right. You cool with that? You should be. Error type. All right. Need to include string. Okay. So yeah. So now all of these just become. Thank you guys for the blessed me's. Bless yous. So print message in 0. What is this? Entity class. Get method. The reason why I contemplated doing this as well is because we're going to need to eventually invoke it. And so it might make more sense to just not care about that and do an invoke and then have this try and retrieve it if it doesn't have it or whatever, and then cache it, and then that's a whole system though. So I don't really want to do that. So we'll just do as start of that, and then we'll do invoke method. So we get method and then we invoke method. And then we invoke that with, I guess we probably want, what are these two? Well, we have parameters that need to be invoked, but in this case, we'll just do null pointer and we won't worry about exceptions for now either. So that way we just do this, and then invoke method is going to be a function that it returns a mono object. So we'll kind of keep that here. And we'll call this invoke method. And then it'll take in a mono method, and then the parameters. So it's very similar to Mono's API for now. Will probably change because we're gonna have, it's gonna be a little bit more different. So what is it? Mono runtime invoke. I don't know why I'm doing this. Let's just copy it. Runtime invoke method instance. Actually, instance is gonna be, but we need to see, that's the other thing, we need to provide a particular instance, right? So actually this is gonna take that, because this doesn't hold an instance. It's not a class instance, this is just a class. So if we invoke a method on an instance, we need to actually also take in the instance, right? So instances is instance, and then parameters will go in here, which we can make null pointer by default. Now do we have, we don't have method here. Let's make sure that's there. Okay, cool. So now we can do invoke method with our instance that we created here. And that replaces this, okay? And then, yeah, we kind of rinse and repeat, really. So instead of this, we just do that. And then when we want to invoke it, we call invoke method. And we invoke that with that. And we don't need this. Same thing here. And here. Monostring new will keep. Invoke method. Yeah, so we've got it the other way around. Which I think makes more sense. Because we're invoking this function like on this object. So it's like this dot that. Yeah. Okay, cool. So that's, yeah, using a little bit more of our API now. Let's just build that file. I've got a little warning here. Oh, this is probably because that's a 64. Or not. Oh, that's a different line, I think. Oh, because of the outsize. Yeah. Let's do the conversion there. No warnings, good. Yeah, so what do we got? Was that all I wanted to do? I think so. Yeah. That's looking pretty good, I think. Let's hit F5, make sure that all works. Cool. Well, this is all working, and this also is doing the same thing it used to do. All right, cool. So that's all there. That's all working. The next step, really, right? And I've obviously called it entity now, so you guys can kind of see where this is going. Now, if we create an entity, We'll wrap up the stream here in a minute, but I'll just show you that when we create an entity, right, let's just say we have a scene, you know, we hit play and whatever, and then this gets created like as an entity. And let's just say it has a script component on it, which we will add next week, next episode. Then that means that when we basically hit play and this kind of spawns in the scene, we basically call this code here to create it, right? All of this code here. And then instead of like retrieving something like print message, we retrieve the onCreate function, although of course we could retrieve the functions ahead of time if we needed to. And you can see, by the way, these get methods thing, they have nothing to do with the instance, obviously. So this is actually from the class itself, because that's kind of what that object represents anyway. But we basically, call onCreate, and then obviously every frame we need to call onUpdate. And that's kind of the gist of how to get this working, basically. And you do that for every object in your scene that has a script component on it. And there you go. That works. So that's what we'll do next week. And then hopefully what we'll do is we'll use that to be able to like maybe move this object basically using like the WASD keys, right? So I want to be able to actually add some logic to this, or maybe we'll move the camera or something like that. Because to move this, you know, we'd have to probably use forces and add all of that Box2D API, which we could do, but we'll see how we go. But yeah, and that's kind of it. Like, yeah, there's a lot of other stuff we want. Obviously, like we want to be able to, once we do that, I think we'll probably move on to having like some kind of way to, once we have a script component, having a way to have like public fields and stuff defined. So inside our entity class that we'll create, which will be, you know, entity will be like the base class, and we'll have another class that is like a subclass of entity. When we have like some kind of field here that's public, we want to automatically kind of be able to pick that up and set its data through here. We'll cover that at some point as well, because that'll be important. But yeah, there's a lot of stuff to do, but it's just important that we get the kind of basics up and running, which is what we've kind of been doing. All right. So I hope you guys enjoyed this episode. If you're watching on YouTube and you did, don't forget to hit the like button. If you want to help support this series and Hazel, and also get access to the big version of Hazel in which all of this is already implemented, then please head over to patreon.com/thecherno. Yeah, thanks everyone for watching on Twitch as well. Every Monday nights, Australian time, we stream this. Twitch.tv/thecherno/schedule. Is where that's at. Stulu08, thank you for the Prime sub. Appreciate the support. Yeah, next week, same time, same place, and we'll continue on with all this stuff. See you guys next time. Goodbye.